In these notes, we're going to look about how to prove that triangles are congruent. And in these notes, we have to do formal triangle proofs. So first, we are going to look at this slide that you see here that has a lot of possible reasons here. Whenever we do a formal proof, we have to give statements, and then we have to back each one of those statements up with a reason. So we'll refer back to this. This is not a list of every possible reason that you could have, but it lists most of those there. So we'll refer back to our list of reasons. All right, so here's our first example. We are given this picture, and in this picture we know that angle N and angle L are congruent to each other because it tells us right here that that is given. Okay, we also know that JK and MK are congruent to each other because that also is given in the problem. So these problems more or less are going to tell us what we need to prove. So right here, if we look at our picture and sort of make a plan here, we see that angle N and angle L are marked congruent. We also see that JK and MK are marked congruent, which gives us one set of sides and one set of angles that are congruent. So we either need another side or another angle, and in this case it's going to have to be an angle. We know that these two angles right here are going to be congruent because those are vertical angles. So if we know that, then we have two angles and one side. The side is not between the angles, so that's going to be side angle side. So that's sort of our plan of what we're going to do. Now, to do a two-column proof, what you're going to do is you're going to make you a little T-chart, and you're going to write statements and reasons. Here. And your first statement should be very easy. You should always get this one right. It's your given. So for your first statement, you're going to say angle N is congruent to angle L, and you're going to say JK is congruent to MK. And your reason for that first statement is always the same. It is given. So if nothing else, you should always get that part of each proof correct. All right, so we already have a set of angles congruent. We already have a set of sides congruent. We just need to say that those vertical angles are congruent. So the second statement that I'm going to make is that angle JKN is congruent to angle MKL. Notice there that I named those angles with 3 letters. We cannot just call those angles angle K because there's 4 different angles right there at angle K. So we must use 3 letters. When you name an angle with 3 letters, the vertex has to be the middle letter. So there, for this angle over here, on the left, I labeled that JKN. So we know those angles are congruent because if we refer back to our list of reasons right here, we see right here that vertical angles are congruent. So that's what we want to use for our reason. Vertical angles are congruent. All right. So now we have 2 angles and a side, and what we're trying to prove here is that triangle JKN is congruent to triangle MKL. And we now know that those triangles are congruent because we have 2 angles and a side. So your last statement is always the prove. So our last statement is triangle JKN is congruent to triangle MKL. And our reason for that is angle, angle, side. So we have verified here that these triangles are in fact congruent. Okay, let's do one that's a little more complicated. All right, here's our next one, and in this one we have AB is congruent to CB, angle C is congruent to angle A, and we also know DB bisects angle ABC. Okay, so we're going to make our chart, statements, and reasons. And number one is always your given, so we have AB is congruent to CB. We have angle A is congruent to angle C. And we have DB bisects angle ABC, and that is given. So here, if we look at this, we're trying to prove that AD is congruent to CD. So what we're going to have to do here is we need to first prove that the triangles are congruent. Because if we can prove the triangles are congruent, it tells me that all of the sides and excuse me, all of the angles are congruent in those triangles. So then we could say any set of sides or angles are congruent. So our first step is to prove these triangles are congruent. And I'm told that DB bisects angle ABC. So if DB, this line right here, bisects angle ABC, that means that it cuts that angle in half. So that would mean that angle ABD is congruent to angle CBD. So that's going to be my second statement. So angle ABD is congruent to angle CBD. And my reason for that is what we're going to call the definition of bisects. Okay, so by definition, bisects tells us that the angles cut in half, so they must be congruent to each other. Now I have angle, side, angle for these triangles. So now at this point, I can say that triangle ABD is congruent to triangle CBD. And my reason for that is angle, side, angle, because I knew two sets of angles are congruent and the side in between them is also congruent. So next, this last step that I'm going to do, now that I know the triangles are congruent, I can say that AD is congruent to CD, right? And my reason for that is going to be this. This is a phrase that we use a lot in these proofs. Corresponding parts of congruent triangles are congruent. Okay, so corresponding parts of congruent triangles are congruent. I will let you abbreviate this to CPCTC, but make sure you know what that stands for. In fact, whenever we get to a quiz on this next week, there will be a question on the quiz that just says, what does corresponding parts of congruent, what does CPCTC stand for? And you have to tell me that it means corresponding parts of congruent triangles are congruent. It just means that the pieces of the triangle are congruent to each corresponding part there. So AD here corresponds to CD. Okay, so we have finished that proof. Let's go on to our next one. Okay, in this particular problem, we're trying to prove that the two triangles are congruent. And we are only given one set of angles. So if we look here, we know angle E and angle G are congruent to each other. But we're also told that DE is parallel to FG. So DE here is parallel to FG. Well, if they are parallel, that means this is a transversal, and it means alternate interior angles there would be congruent. So we have really two sets of angles that we can know. We'll have to prove that second one there. And also, they share a side. DF is congruent to itself. So that means that we have angle side here. So we can prove these triangles congruent. So it's always good to kind of think of the plan that you're going to use to do the proof before you begin. So to begin, we've got statements. And we've got reasons. Okay, and for number one, we've got DE is parallel to FG, and angle E is congruent to angle G. And our first reason is always given. So we've got that down. So we got two things that we have to declare here, and we can do them in a different order. We must say that DF is congruent to itself. We also must say that angle EDF and angle GFD are congruent to each other. So I'm going to start with DF being congruent to itself. So I'm going to say DF is congruent to DF. Now, that almost seems like that's a statement that doesn't need to be said. However, it does, because in order to do these problems, you have to have listed the three parts that you have declared congruent before you can say that triangles are congruent. The reason that we use for this is what we call the reflexive property. The reflexive property tells us that anything is congruent to itself, which is sort of a given, but it must be stated here. So anytime you need to say they share a side, you're going to state that piece is congruent to itself, and then you're going to use the reflexive property. The next thing we're going to do is we're going to say that angle EDF is congruent to angle GFD. And angle EDF is congruent to angle GFD because if you look in the picture here, those are alternate interior angles. And we know that if parallel lines are cut by a transversal, then alternate interior angles are congruent. Technically, we should write out that whole long sentence, but I'll let you get by with just this. Alternate interior angles are congruent. So alternate interior angles there are congruent. Now, I have stated right here that one set of angles is congruent. Here, a side is congruent, and here another angle is congruent. Notice the side is not between those two angles, so we're going to say that triangle DFG is congruent to triangle FDE, and our reason is angle side. And that is what we wanted to prove, so we are done with this proof. Okay, let's go over to this last one, or this next one here. This is a 2-column proof, but this you'll see a lot. And if you see this on your final exam, it'll probably definitely be this way. This proof is already partially filled in for you. If it's on your final exam, it will be like this because it has to be multiple choice to be able to ask these questions. So here we see AD is congruent to DB, and C is the midpoint of AD. And we are supposed to prove that triangle ABC is congruent to triangle DBC. So we see here AB is congruent to DB. That was given. We also see C is the midpoint of AD. That is also given. So here what this proof has done is they have split their givens up into 2 separate statements. So that sometimes will happen. For 3, we see the reason is definition of midpoint. A midpoint, by definition, is in the middle of a line, making the 2 pieces of a line congruent to each other. So if C, right here, is the midpoint of AD, that tells us AC is congruent to DC. So we're going to say AC is congruent to DC. And that reason is the definition of midpoint. The next statement that we see is BC is congruent to BC. We just did that in the last problem. Those 2 triangles share that side. That side is congruent to itself. When we have that, we use this reason, reflexive property. Okay. And then the last statement that we have is that triangle ABC is congruent to triangle DBC. And so triangle ABC must be congruent to triangle DBC. They share this side right here, so it's congruent to itself. We also know that these 2 sides are congruent, and we were given that the 3rd side was congruent. So that tells us that we are proving this by side, side, side. Okay, your assignment that you're going to have, the substitute is going to give you a worksheet, and on that worksheet, you've got a lot of proofs that you're going to look at. Your assignment on that worksheet right now is just to do numbers 1 through 5. Those are required. And some of them say things like write a flow proof or a paragraph proof or something like that. You do not have to do that. Write a 2-column proof for all of those. You may work with your partner as you work to try to figure those out. If you get all the way through 5 finished, you can go ahead and work on some of those other problems because we will be looking at those problems in tomorrow's class as well. So you'll be a little bit ahead if you do some of those extra. Please do your work on a separate sheet of paper. Don't try to squeeze everything onto that paper. So on a separate sheet of paper, please. Okay, and go through and work on those for the rest of the class.